Welcome to The Explainer. We're diving into some really fascinating new research today, and it all boils down to one question. What if an AI could actually learn to reason, all by itself?
Yeah, I mean, can an AI actually teach itself to get smarter? We're talking no outside help, no human looking over its shoulder, not even a simple answer key to check its work. Now, to really get why this question is such a game changer, we first have to talk about a huge bottleneck in how we train AI right now. Okay, so here's the deal. Teaching an AI to do complex stuff, like math or coding, is super hard. It's expensive, it's slow, and it pretty much always needs an external teacher. That could be a human expert giving it feedback, or it could be a perfect gold standard answer sheet for the AI to grade itself against. The problem? That whole process is just not scalable. It's a massive roadblock.
All right, so let's break down the old playbook. How have we been doing this so far?
So you've basically got two main methods. On one side, there's RLHF. Think of this like a human coach on the sidelines, giving a thumbs up or a thumbs down. It works, but man, it's slow, expensive, and humans can be biased. Then on the other side, you've got RLVR. This is like having the perfect answer key for a test. It's awesome for clear-cut things like math problems, but what's the catch? You need those perfect answers. And for most messy, real-world problems, they just don't exist. So all these limitations, they really corner us into asking a huge critical question, one that could honestly flip the script on how we build AI. And that question is this. What if a large language model could get better at reasoning by just thinking? Seriously, what if it could improve by relying only on its own internal self-generated signals? No outside help, no rewards. If that's possible, well, that changes everything.
And this is where a really cool new idea comes in. It's a new paradigm called reinforcement learning from internal feedback, or RLIF for short. And we're going to look at a specific new method that actually pulls this off, and it's called Intuitor. So the whole point of RLIF is to get the AI to learn from its own internal signals. Instead of needing a person to pat it on the back and say, "Good job," the model literally becomes its own teacher. But wait, how does it know if it's right? How does it grade its own homework? Well, this is the brilliant part. The answer is something called self-certainty. You can think of it as the model's own confidence level. When it comes up with an answer, it also basically asks itself, how sure am I about this? The more its answer stands out from just being a random guess, the more certain it is. And that certainty, that becomes the reward. And this method, Intuitor, puts that idea into a really simple, elegant loop. Here's how it works. First, the model spits out a bunch of different possible answers to a question. Then it scores every single one of those answers based on its own self-certainty. And finally, this is the key, it rewards itself for the answers it was most confident about, and it tweaks its own internal wiring to get better at finding those confident answers next time. It's a totally self-sufficient learning cycle. It's learning from itself.
Okay, so the theory sounds amazing, right? But does teaching an AI to trust its own gut instinct, does it actually work in practice? Let's check out the data.
So when they tested this on tough math problems, the results were, well, they were pretty mind-blowing. The traditional method that used the perfect answer keys, that's GRPO, it did a little bit better, sure. But look at Intuitor. It got so close to that gold standard performance. And here's the kicker. It did it without ever seeing a single correct answer. It just learned by rewarding its own confidence. That's incredible. But hold on, because this is where things get really wild. The researchers then did something unexpected. They took these models that were only trained on math problems, and they threw them at a totally different task, writing computer code. The model trained with the answer key, it barely got any better at coding. But Intuitor, its coding performance nearly doubled. Just wow.
And this discovery it's profound. What it means is that by rewarding its own self-certainty, the model wasn't just getting better at math. No, it was actually learning something much deeper. It was learning a more fundamental, structured way of reasoning that it could then apply to a completely new domain, like coding. It was learning how to think better. So let's step back for a second. What are the big picture implications here? What does this mean for the future of AI?
Well, first off, this isn't just some clever lab experiment. This points toward a future with much more autonomous AI, systems that can learn and get better without a human constantly holding their hand. It also means we get models that are better at generalizing, at taking a skill from one area, like math, and applying it somewhere totally new, like coding. And because the model's sense of certainty is always evolving as it learns, it's way harder for it to game the system or hack its own rewards. But maybe the most exciting part? This could be a way for AI to make progress on problems that are so complex, we humans can't even verify the answers anymore.
So yeah, this research really kicks open the door to AI systems that can improve through pure digital introspection. It's a huge step towards a more autonomous, more general form of artificial intelligence. And it leaves us with a pretty provocative question to chew on. What happens when an AI doesn't need us to get smarter anymore?